So, hello everyone, I am Kamala from Primary Department. I am here to explain the project we took for the Project Expo 2025 organized by the Department of Electrical and Electronics Engineering. Our project title is Servo Motor Based Prosthetic. So, I will be giving the brief introduction of the project. Our project motto is to create a prosthetic arm for the people who lost their day-by-day life by meeting the situations like accidents or by the birth. So, our aim is to create a prosthetic arm for the people who doesn't have proper hands for making their day-to-day life better. So I am Kamal and this is my friend Gokul Krishna. He is my friend Haribabu and he is Haribalaji. So the further project will be explained by me.
We have two modes of operation in our product. Whereas the first mode is the EMG mode and the second one is the voice control mode. In the first mode of operation, we have used EMG sensor, which is nothing but the muscle sensor, which is used to convert the muscle signals into the electrical signals, and thereby the servo motor works. By working on the servo motor, the corresponding fingers, we have placed 5 servo motors over here, which corresponds to 5 different fingers in our prosthetic arm. Moving on to the second mode of operation, we have used voice control mode, wherein we have used HC05 module, which is nothing but a Bluetooth module, which is used to convert the voice command that we give into the servo motor action. These are the major two modes of operation that we have implemented in our project. Moving on, we have used a couple of components such as Arduino Uno as a microcontroller, and we have used electrodes over here for detecting the muscle actions, and 5 servo motors as I mentioned earlier. We have used 3D printing. ABS plastic it is more comfortable for the users to use, and also we have used lithium-ion battery as it can be reused again and again, and some of servo motors and OLED display. Moving on to the proposed methodology, my friend Haribabu will be taking over it.
As Gokul said, we have two mode of operation. First, proposed methodology mode 1. We are using a EMG sensor which based on the screen, which detect the neuron signal and amplified with the EMG board. Then it sends back to Arduino Uno. Then the process will be taking place. Then the servo motors of the limbs are controlled by the Arduino Uno.
As you can see over here, this is the EMG mode of our prosthetic arm. As you can see over here, we have connected 3 electrodes to the veins of the person, and correspondingly we have connected an EMG sensor, which converts the muscle signals into the electrical signals, and thereby the servo motor works. As you can see it over here, the EMG value varies from 300 to 1 or 2. As the person contracts and relaxes, the value of the EMG changes correspondingly.
Coming to the mode 2, which is a voice controlled prosthetic arm, where using a HC05 module, which is a Bluetooth module, which is connected to the Arduino Uno. From that, we are using a mobile application which transmit data through Bluetooth, which is connected to the HC05.
Right.
Based on the user input, which will be a command specifically open or close. Based on the commands, the servo will contract or relax of the prosthetic arm. Now, Aripology will take that.
Gap identification. Gap identification is nothing but the difference between our prosthetic arm and their prosthetic arm. First, we can check about height cost. Our prosthetic arm is less cost and compared with the other prosthetic arm, and weight is around 1 kg, and the other prosthetic arm is around 2 kg, 2.5 kg. That times you can see that, and we can easily adapt our prosthetic arm and compare with the board. And less comfort. It is less comfort because we are using the plastic material, so it is less comfort you can see. So impact. You can see the impact, positive impact and negative impact. Positive impact, lip movement and perform variable activities and physical manipulation of the things. And negative impact, you can see, may express several pain, you can feel that, and extra weight you can feel. And next, the ABS material. We are using well certified medical ABS material. We can research with the doctor and it is well certified ABS material. system implementation. Using the Fusion 360 3D software, we have designed our prototype prosthetic arm, and we can use the circuit diagram. This and all we are using Tinkercad. That time we are using, and Arduino is using Arduino code and output here. So features, and we are going to talk about the difference between our processing arm and their processing about the features. First, feedback mechanism. No such feedback mechanism are present in other processing arm. Our processing arm, we have OLED display. It shows real-time based servo motors running or not. We can check the heart rate also using the OLED display, and power management. Their processing arm battery solutions very less, and our processing arm we can using lithium-ion battery. It is rechargeable also, and data processing. We are the same algorithm also using software that will be, and sensor integration. Other processing arm they are using the operation and they fix the limb, and our is we are using the EMG sensor. Using EMG sensor, you can easily get the muscle sensor. So this compared, and cost efficiency. Other processing arm high cost and less affordable. Our processing arm is less cost and more affordable. And comfort and weight. Our processing arm is less comfort compared with the other processing arm. And material we are using. Other processing arm using aluminium or metal. This is due high cost. So our processing arm is less ABS plastic well certified medical plastic material we are using, and flexibility and manufacturing. Less flexible and manufacturing with other processing arm. Our processing arm is more flexible and easily manufacturing done. Customer there is high degree of customization and can be found, and our processing arm is sitting with limited user customization. Existing startups. These are the existing startups. We have researched a lot of startups, DOS Labs and Dash Bionic, Robo Bionics. These are the startups we have researched. You can see the price range is around 2 lakhs to 5 lakhs, 1 lakhs to 3 lakhs. Located also located in Pune, Maharashtra, Bangalore. These are high cost of manufacturing cost. Difference between our processing and their processing is our processing is less amount. It's around 30k, 40k budget overall amount. Market research. Targeting audience hospitals, we can collect all the data from hospital who are lost their limbs, and arm manipulated. Partnership with the hospitals using advertisement. We can advertisement our prosthetic arm, and global prosthetic arm market. And you can see CAGR is in 2022 to 2024. You can see 9% is CAGR, and in 2024 global marketing sizes 2 to 5 billion marketing price.
Moving on to the work process, as you can see over here, we have placed the OLED display which gives real-time feedback for the users to rectify the errors if there is any error in our prosthetic arm. As you can see over here, it shows initializing the number of servo motors that works initially. If there is a defect, it reduces the number of servo motor counts by 4 or 3. Depending upon the number of servo motor that works, it gives the real-time feedback in the OLED display. Moving on to the conclusion part, which will be discussed by Kamal.
So, conclusions and future scope of this project. The main objective of this project is to make the life better for the people who lost their day to life due to the accidents or by the birth. So, our main advantage of our project is we are having an EMG-based muscle sensors and also the voice command mode. And I will be showing the future scopes of the project. The future scopes will be, we will be adding touch recognition and pitch grip technology and fork charging system, and we will be adding solar charging system. So the main upgrade will be the solar charging system, because we are using the lithium-ion battery. So for that, every time charging with help of the renewable energy will be very useful for the people. So we are trying to implement that in the future. Thank you.